Hey guys, welcome back to the shop. I'm Dave. What am I going to say here? On my videos, when I first started, got the lathe and then the end mill, there weren't any YouTube channels out there that really were towards this. They were just the big machine shops, and it seemed like there were three very popular shops. One was Keith Fenner, Adam Booth, and Tom Lipton. And of the three, I watched a few of each's video, and it seemed like Tom Lipton was more into teaching things, because I watched a few of his Monday Night Meatloafs, and you'd see comparisons on cutting fluids and things. So I had watched every single one of his videos from number 1 to Monday Night Meatloaf 100, and then decided to, I figured I was far enough along that I kind of knew what I was talking about, would make an idiot out of myself. So I dedicated this channel towards the mini mill and mini lathe and how I progressed and learned through things. So if you go to my website, theminimachineshop.com, you'll see a link to the channel, which will give you a nice order from number 1 all the way up to, this is probably 71 now. And you need to watch them all in order to see how I progressed and how I did things. So if you're the newbie out there, I highly suggest that you just watch all the videos from number 1 up. In this video, I've had a lot of emails and comments on different things that I made. How did you do this? How did you do that? So in this video, I'm going to take you guys over to the bench behind me, because it's got really nice lighting and I can close the garage door and you don't hear cars driving by. And I'm breaking it into little segments, that way I can take out individual items on the bench and stay focused on that particular subject. So I apologize for the different breakups, but let's take you over to the bench. Never fails, always in the intro I forget to mention something. As of right now, I've got 769 subscribers in the control panel for the channel, but it says only subscribers who share their subscriptions publicly are shown. So I'm kind of curious. I guess I looked through my panel and I can't find anything where you can just hide your stuff. So I don't know what they're doing. I was also curious too, 700 people subscribe, but usually the videos that are published only get 200 or so views. But just wanted to share a little information, that my thoughts on mics. You always see the big shops use a mic only when they're checking their work, and it's because it's the most accurate device that you've got in the shop, because you can actually measure tenths by looking at this thing. And I bought this because I'm just not that great with this guy coming up with the numbers and stuff. I'm making mistakes, and I did check this guy. Actually, I'm going to check this guy too. This is a gauge pin, 1/4 inch, 0.250. And when you're trying to do tenths, I keep doing this because grease counts, grease and dust. Let's see if I can even figure out what this is going to be. Oh, right on it. It's just a hair over the line here, so can't tell. This is a class ZZ gauge pin from a plus set, which means that this can be 0.250 minus 0 plus 0.2. So let's see what this guy's going to do. Look at that, 0.2501. So it's a tenth over. This guy does advertise that it's accurate to a tenth. So, and I'm guessing that these guys, all of them, doesn't matter how much money you spend, these are only accurate to a thousandth, even though they'll display that half thousandth mark. And what's this guy going to increment? Because he's got the little, another one down there, oh, it's 5. So he can tell you maybe a half a tenth, a thousandth accuracy. But in any case, this guy, yeah, knew it's really expensive, and this was on Amazon. I think it said it was used or returned, open, something like that. So I was a little nervous, but it was I think it was around $70. Otherwise, it's way over $100. This one I bought because, like I said in one video, a machine friend called me, said Amazon mismarked it. They marked it as like $10, and it's supposed to be way over $100. So I just wanted to let you guys see this and why I bought them. First up, a viewer in the UK wanted to know and see how I made this little dovetail cutter that makes the dovetails for the test indicator. And this guy is small, let me tell you. The diameter of this thing is 0.173. What happened was, this is made from W1 water hardened tool steel. And what I did was just get the 60-degree angle, and I just came in and cut the angle there, completely wrecking a carbide insert doing it, but it hung in there long enough to get that angle on there. So, I spun this first, the whole outside diameter, and then just plunged in carefully and slowly with lots of lubricant to get there. And I didn't I didn't quench this thing because I figured it's got to be hard enough, and all I'm going to do is be cutting aluminum anyway. I'm not going to try this on steel. After that was made, this was taken over to the mill, put in the Spindex 1/2-inch high-speed steel. What did I use? No, I must have used a carbide. Oh, dirt on it. Wow, where does that come from? Yeah, got to clean that thing up. Oh, it's all over. I just plunged in. This was in the Spindex, so I could make sure I could just rotate this perfectly. And I just plunged, excuse me, I plunged down in till I was probably 10,000ths from center. So I had to find the center first, set the DROs up. And then I was just guessing, I think, at this distance, how far in I was, but that's all I did. And then once it was made, and the edges are pretty sharp, I didn't try to hone this or anything because it's just way too small for me to do, and I figure I'd mess it up if I tried to do anything with it. The bottom, did I touch the bottom? No, I didn't even touch the bottom of it, so no, I must have, yeah, because the end mill would have left burrs on it. So I probably ran this carefully on a surface to clean it up. But that's how I made this little guy. Next up, I showed making this block, cutting this guy all up, but I never showed exactly how I attached this part to the tailstock. This guy was machined so that when this is attached, I've got a 20,000th gap underneath here, and I was planning on using double face tape or something to keep this there. I didn't want to bolt it on. And the reason for that is in the video I did on the mill unboxing setup and upgrades, I mentioned the DROs, and that if you have any force on the DRO sensors this way, any which way, you're going to get erroneous readings. And because of that, I kept that in mind with this guy. And I don't think these are as sensitive as the DROs are, because you're pushing on it with your thumb. And you go back and forth and it always zeroes out. Doesn't seem like you can push it any which way to make it screw up. But in any case, I wanted this guy to be nice and straight and reliable. So I calipered from here to this edge and made sure that from here to this was the same distance. Tightened the screw down so I know I'm straight that way. I pushed this guy all the way up against the block, pulled the block out a bit, hot glue. I let the gun get as hot as it could possibly get because I know this is going to be a heat sink and I didn't want it cooling off very fast. Quickly put a dab here and then push this guy back. And then just let it sit and cool off. And it looks like it's perfect because I'll caliper from here to here and this gap here, and it's right on the money. So that's how I did it, and if you're doing a DRO upgrade, I wish I would have thought of that when I was making it for the mill, because that might have come in as a nice trick on keeping forces and tweaks off of the DRO sensors. But that's how I attached it, guys. Next up, I figured for the lathe I probably need something that's going to tell me where the saddle is when I'm boring, because a lot of times I need to bore to a specific depth. Now, I did buy, this is another one of those carbide or carbon calipers, really cheap off of Amazon, and I know it only goes to 1/10. I'm not sure if I'm really going to need anything more accurate than that. I may someday, so I may wind up building another one. But the idea was, again, because of the DROs and the sensitivity, I use neodymium magnets. There's one here, and there's one on the face here. And I wanted this removable because if this stayed permanently on the lathe, I know it's going to be a pain to clean under. So I wanted to make sure it was removable. I could put it on there when I needed it and then just get rid of it. And it seems to work. This goes on the saddle, this hits the saddle, this is on the ways on the back where it's flat, and it stays straight. And it looks like, because I did a dial indicator and stuff and checked, and it seems like it's right on the money. It's not moving at all. So just a cute little toy. Let's see how it works out in the shop when the time comes. In the last video, I mentioned that I made the threading and tapping crooked problem go away, but I don't think I've ever really clearly stated what I did to make the problem go away. This is the original die holder that I had made a long time ago. The die just drops in, and I had one set screw. The problem with this guy is there is too much wobble this way, and the one set screw allowed this guy to go crooked. So that was a problem, and got rid of that by making this guy. I think everybody's seen this in one of the videos. The final boring on this thing was done on this arbor, where it was in the lathe with an adapter in the spindle. So, and the hole was drilled all the way through. So I know these set screws are perfectly straight in alignment. The die goes in there, and what I do is I look at this back surface after I did the set screw. I'm peeking down in there to make sure this is absolutely flat. So that made that problem go away. In addition, with the other guy, what I figured out I was doing is I would start the threading until the item was poking out just a little bit, and then I'd release this guy, or it was actually this one, release it, put a crank on this guy, and then finish the rest of it by hand. That was the mistake. You cannot thread straight by hand. I think it's impossible. I used to, I don't know how to explain, but maybe I shouldn't say impossible, but I cannot thread by hand. You have to use the machine completely all the way, like I did on these guys. These were completely threaded in the lathe. Why did I buy this set? This is simple. Irwin, which is Hanson, I guess. My dad was a tradesman, as I mentioned, a steam fitter, and on all of his jobs there were always Hanson and a couple other manufacturers. They're supposed to be high quality. The set that I bought 35 years ago it was foreign, wasn't China, but it wasn't making nice clean threads. They weren't shiny, they were rough surfaced, so I figured I better just get a nice US made set. Going on Amazon, as I always do, here's the whole set from Irwin. It's Hanson, supposed to be US made, they all say USA on them. And on that site, there's always the picture of the item on the right, and on the left there's other pictures you can click on so you can see different angles of it. On that particular site, there was a video produced by them, that I watched, and the amazing thing was it was promoting that this set is for threading. They show threading with it, even though now their website says this is not a threading die. The video showed that there is a unique patented design to this particular die, whereby if you're doing it by hand, the angles of it and so on, keep it straight. It will automatically, or I don't know how to describe it, but it's supposed to thread straight. It doesn't do that. Let me get the piece here. Forgot to get it out of the scrap bin. I had taken a piece from the scrap bin, here it is, and threaded it completely by hand. That's a 1/4 inch aluminum rod that wasn't touched. It was stuck in the vise. I had the wrench on this thing that you're supposed to use, and I just completely threaded it. And you can see that that's about as crooked as it gets. So these all threaded completely on the lathe, and it doesn't get better than that, guys. Even the tapping was done completely in the mill, and I'll explain here in a bit about tapping. Look at the gap on that. That is just perfect. So that's what I did to make threading go away. Tapping straight was the same issue. I would chuck the tap up in a truck, drill chuck, in the mill, and then come down applying some pressure with the quill feed or whatever you want to call it, and using the crescent wrench I would start the threading. But I was always afraid if I was applying too much force to the tap or not enough force that I'd be starting the threads out bad. So what after I get the tap started, I'd release the chuck and then finish the tapping by hand with the crescent wrench, which everybody's seen. You can't do that. Again, you just cannot thread or tap by hand. It goes crooked somehow, some way. So making this guy with the spring on it, I can chuck this up or put it in a collet, and I come down on the tap. I know I'm perfectly straight and I'm applying pressure, and I just keep tapping all the way down by hand. No, not by hand, but with this guy on it. So that's how, again, this whole set of thread protectors was made completely all the way through on the lathe. I never released this guy at all. Well, I did release it because I had to get the tap out to get the garbage out of there. Put the thing back in and put this back on it, and then tap deeper and keep going. So I had made, let me get it, an entire set of thread protectors, which comes in really handy. I've got, this is the Imperial set, and I've got a metric set, and they allow me, like when I'm making this guy, I can machine everything here, and when I'm done, you cut it off, and then I can put it in this guy, in one of the thread protectors, and I can do the facing. Sometimes I'll actually have to put a nut behind there or something to keep it out, so if I wanted to refinish this thing, I could. And by the way, this was one of those that was done with this die, which didn't cut the threads all the way. So I did put this back in the mill. I put it in between two pieces of plastic, acrylic, clamped down pretty hard on it, and then ran this over it. And yeah, it was by hand, so I was risking going crooked, but it didn't go crooked, which was really lucky or nice. But the point is, it didn't mark up this face at all. That was in the vise, in between acrylic, tight, and I know I was moving it this way, because I saw it moving as I was trying to carefully with a crescent wrench run that down. But that surface is absolutely perfect. So acrylic makes really good soft jaws. It could have marked that up and didn't do anything to it. In case you're wondering who made most of the taps or where they came from, I think just about all of the taps are from my dad, and most of them are ACE, A-C-E. and that's what he used on the job. And even the small guy, that's an ace. So I'm probably going to research out ace. I wonder if they're really expensive or what. Because I know they make hexagon ones, but I wonder if they make one to replace that. But let's see what Irwin says. I did, stumbling around this morning, finally found a Contact Us page on the Irwin. And so I did send them private, I guess, like email saying, you know, I've got a defective die and a link to the video. So let's see what their response is. Alright, all the numbers are in the screen. And I forgot on this guy, at one point I said I did the thread protector in the middle. This was done on the lathe. 1/2 inch stock, clean up the outside so I know that it's straight. Drill it out and thread it completely through and deeper on it. And to tell you how just perfect this is, this guy was finished in this thread protector. So I did the face and then I chamfered the edge, and you can see, I don't know if you can see the reflection or anything of that, but that chamfering is perfect all the way around. If there was any wobble or anything off on it, it would be big and small lines or whatever. So that's my 2 cents worth on that. This, for fun of it, I decided, and move it down a little bit more, yeah. I decided to just drill the heck out of my 3-jaw 4-inch chuck. Now the 3-jaw, if you go to the website, you'll see a picture of it. It says Shop Fox on it. I did buy it a long time ago from Amazon. It said it was supposed to be Steelex. Ordered it. When it came, it just happened to say Shop Fox on it. These are the jaws from the 3-inch. I just have it out here, I guess, for visual aids. What I did was, there's jaw 1, 2, and 3 from the 4-incher. I measured the width of it, each jaw. And I used that 10th micrometer. I measured here, here, and here with the mic, and came up with these numbers. So it's 6, 4, and 5/10, because these look ground. The surface on them looks like it's ground. And yeah, it's pretty accurate. You know, there's like 6/10, 4/10, 5/10. And second, no, this would be jaw, okay, yeah, face. So this is this point on jaw 1. This is the midpoint center on jaw 1. And this is the back on jaw 1. So you can see 6, 4, 5, 4, 8, 5. I don't know why that's up there. And 5, I had grease, so this might be just grease in the center, and I didn't clean it, because this was 10. After I wiped it down, I came up with 5, 6, 5. So the 4-incher jaws are pretty flat and accurate. Next thing I did was I stood each jaw up, because I was looking at this bottom edge going, hey, these look like it's all ground. So I stood it up like this in device, in the mill, held it, clamped it down. Now, what am I doing here? I'm measuring from here to here and here to here. So this is the front. No, this is the top. There we go. I tried measuring that with the super accurate mic, but I couldn't get consistent numbers, so forget all of that. Here's the top and the bottom. So it was, I measured the top from here to here on jaw 1, and then jaw 2 and 3. So you can see 8,000, 7,000, 6,000 difference. So that's pretty close. And then I measured the bottom. So I got 7,000, 6,000, 3,000. This is way off. But I was doing it primarily with this guy because, like I said, the mic, I couldn't really get consistent readings. It was all over. And this, I could repeat the readings quite a few times. So I think this is pretty accurate. But then the last thing I did was I set it up, and like I was saying, this looks like it's ground, so I set this in the vise in the middle and held it down and clamped it. Again, this is the wrong jaw, it's the other set of jaws. And since the test indicator doesn't have that long a stem, I could only go down so far. And the other jaws, these, it's one smooth surface, but the other jaws has actual fingers or whatever that poke out. So I was only able to measure the first 3. And what I would do is like zero out the x-axis on the test indicator. Now I know in previous videos that the camera has better eyeballs than I do because I'm editing videos and I'm going, yeah, look at that needle, it isn't moving at all, 0 run out, and I'm looking at the video going, what the hell are you talking about, Dave? It's moving a half a thou. So I was very careful in making these measurements, all of these measurements, and I used magnifying glass on this to make sure that the test indicator was truly zeroed out, and then I'd move it down to the next one, made sure I was absolutely on center too, and didn't move anything. I'm just going straight down and measuring it. And so first the zeros, the next one I've got 6, 0, and 0, and then the next one down, what have I got? Oh, there's 0. Okay, 0, 0, 0, and then I've got 6, 0, 0, and then I've got 4 tenths, and minus 2.5 tenths, and then minus 4 tenths. Now this is all kind of iffy because I don't know what the tram is on the middle, but those are pretty darn good numbers. Now on that chuck a long time ago, I know I was having run out issues and different problems holding it, so I did make, again this is the wrong set, but I did make a ring. I turned the ring and stuck it on the jaws and expanded it inside the ring, and then I went in there with a carbide boring tool and just barely touched all of them until I could hear it was like TT, it was hitting all 3 teeth. So these measurements are from the jaws that were turned in this ring. I could have really wrecked it because that's the wrong way to do it. You need to be clamping, not expanding, but I lucked out. And the last one I did was I took 2 gauge pins, 1/4 inch and a 1/2 inch. And again, with the magnifying glass, very careful on what I was seeing and measuring and writing down. I put the gauge pin in, clamped it down, had the 1,000th run out on it. I undid the gauge pin, just rotated it a little bit, reclamped it, and I had 1.8 thousandths run out. Did it a third time, I had 9 tenths. Did the same thing with the 1/2 inch, 2 thousandths run out, 6 tenths, 1.6 run out. So summary on the 3-jaw chuck, just clamping it. You know, you can machine it so that it's perfect. You still got scroll issues, you got contamination issues, and yeah, let me bring the chuck over here, even if it's a small one. Here's the little 3-inch. Before doing any of these tests, I did full chuck maintenance, and on the surface down here that this rides on, I just wiped it off, and it's like filthy dirty. So looking behind it, you know, at what would it be? It's what this surface rides on. You can see all kinds of garbage in the 4-incher, and there's no real way unless I make a special tool to clean that out. But again, you know, I think collets are probably the best thing that you can use, because you're going to use even a 4-jaw. Well, no, a 4-jaw you can adjust it, but who knows anything about wobble or whatever in there. And in the next video, I had an idea on how to check for all of that in a chuck, so I'll be showing that in the next video. But for now, this is just beating it to death, showing that 3-jaw chucks, 4-jaw chucks, I don't know. Don't try for accuracy. I don't think you're going to maybe get it. I don't think.